as cosine and sine, right? So cosine at pi is a negative 1. So this is like saying sine x times a negative 1 minus, and then here we have cosine x, and now we look at sine at pi, and sine at pi is 0. So this one, this right side, that goes to 0. And so we end up with negative 1 times sine x. That would be negative sine x. And that equals to our right hand side. Okay. And now on a problem similar, now we're still proving identities. So if we have a problem such as number 36, we have 1 minus tangent x tangent y. And we want to prove that equals to cosine x plus y over, in parentheses, quantity x plus y in parentheses, and cosine x cosine y. Okay, so if we take the left side and we make this 1 minus sine x over cosine x times sine y over cosine y, and we look at that and we go ahead and get a common, change 1 to where we have cosine x cosine y over cosine x cosine y. So we're going to multiply to where we get a common denominator from the 1, so we need to multiply that as cosine x cosine y over cosine x cosine y. So we're going to get cosine x cosine y over cosine x cosine y minus sine x sine y over cosine x cosine y. Alright, and from there we go ahead and combine them into one denominator, right? Because that's what we have here on the right side is one common denominator, cosine x cosine y. So here we have cosine x cosine y minus sine x sine y, and that's all over one single numerator cosine, or denominator cosine x cosine y. And from here, cosine x cosine y is equivalent to the difference equation, or the sum equation for cosine x plus y. Because if you look at the cosine x plus y, that's cosine x cosine y minus sine x sine y. So we're going to change this numerator here to cosine x plus y, and that's going to be over cosine x cosine y, and that's what we wanted. And so that's our right hand side. let's say that we have secant pi over 2 minus u. And we want to prove that that is equivalent to cosecant u. And it works the other, this process works the same if we had cosecant u and equals to sine u on the other side. Okay, so we know that secant u equals to 1 over cosine. Alright, and it doesn't have to be u, it could be x. Secant x equals to 1 over cosine x. So we're going to change this to 1 over the whole thing of cosine, parentheses, pi over 2 minus u. And so now we know that cosine, now this goes back to cosine s minus t is equal to cosine s cosine t. Make that a little clearer. Cosine s cosine t plus sine x, sine s rather, sine t. Okay, so this we're going to make this 1 over cosine pi over 2 cosine u plus sine pi over 2 sine u. And in our, at pi over 2, we know we have that coordinate point, x is 0, y is 1, cosine and sine, right? So cosine at pi over 2 is 0. So this would be 0 times cosine u plus sine at pi over 2 is 1 times sine u. And so this 0 times cosine u, that just goes to 0, right? So, and then 1 times sine u, that's just sine u. So we have 1 over sine u, and we know that sine is a reciprocal of cosecant, so this becomes cosecant u. And that's equivalent to our right-hand side. And so that's how we do secant and cosecant. So now if we wanted to start with cosecant on this side, on the left side, then we will put 1 over sine, pi over 2 minus u, and then work 1 over, and then work the sum or difference formula for sine, in this case. And then go ahead and flip it back at the end. Okay, and that concludes lesson 18.